speed.
Okay.
Once you see a car is in front of you, you will have to hit the brake or cancel to disengage the cruise because you don't want to hit them, of course. With adaptive cruise control, what it's going to do is that you're going to be cruising, and if there is an object or a car in a certain distance, your car will reduce your speed to match up to theirs on its own. And once that vehicle moves out of your way, it's going to speed back up to whatever you set the cruise at.
Okay.
So this is not a new technology. Conventional adaptive cruise controls uses sonar sensors to measure distances, but for longer distance it uses LiDAR, laser, all that. But they are very expensive modules and certainly not in our scope to build it. So what we wanted to do is we wanted to cut the cost down to the bare minimum and still have something that works. So what we wanted to do is use a vision system. So all it takes is a photo from your dash cam or any camera for that matter, your phone, everything works. So this is what it's gonna do. It's gonna take this picture and analyze that picture and tell you how far that car is
Okay.
just from one picture. I can use the same technology to take a picture from here and tell someone from over there how far they are. Would you like to see the demonstration how we
Yeah.
do that? Okay. Pull up the samples. So these are some pictures I took on Riverside Drive yesterday.
Okay.
So I wanted to measure the distance from this car in different scenarios, how far it is or how close it is. Okay. Turn up run the program. So for this picture, you can see if you drive, you have some experience and you'll see how far a car is. And you can see this car, once it measures, it says this car is at 48 meters. So these measurements are on in millimeters. So if you scroll down, let's say something a little bit closer, scroll down furthermore. Further. Like for this example, right? This car, by analyzing this picture through object detection, we can tell this car is at 17 meters away. Scroll down to the bottom. This is a Tim Hortons drive-thru, and this car is pretty close. And once you analyze it, you'll see it's at 2 meters away. Okay. The way we analyze it is we use the focal distance of our camera, which is fixed. We use the object height in real time. So for a sedan, the standard height is 1,445 millimeters. Of course, it changes every now and then, but that is something we also have to imply and detect what kind of car it is. Then we use the image height, which is the pixels, how many pixels you have in the image. And we use the data of, can you scroll down a little bit? Okay. So this car, how big it is in terms of the picture. So we have 1,200 pixels over here in terms of height. This car takes about 1/4 in the picture. So we use that data to calculate what the distance is. That's why where our object detection comes in, because if you look at here, you will see the box that's drawn around there. That tells us what's the height of the vehicle is. And that distance that we have, with trial and error, we measure with tape measures, and with people and with bicycles, it's almost always accurate. Okay?
So the main thing that matters is like how far from the things, right?
The distance, that's what I need for adaptive cruise control, because if the car is too close, I have to slam on the brake. But if it's going away, we can measure like, oh, it's going away, we can speed back up. Okay?
Oh, that's why you need all the heights and stuff?
Yes, that's why I need the distance. Now, I can show you how the adaptive portion works with a smaller scale. We have the sonar sensors, and we're going to measure the distance of it, and we're going to show you how the sonar sensor works.
Okay.
Dano, you want to spin the sonar?
Yep. So for the sensor-based part of this system, we have used an ultrasonic sensor, and this is running natively on Raspberry Pi using Python code.
Okay.
And well, if you see here, this is the code, and this is the Python shell for the results. And if I start running the code, right? So right now it's 0, but if I press the gas, you can see the speed going up, right? So, and if I let it go like a normal car, it will start dropping the speed, right? And I keep going back, I can keep pushing it up. So we have a regular cruise control system where it will just stay at the desired speed, right?
So this is basically to just control the speed of the...
Yeah, this is manual control. Yeah. But if I switch to adaptive cruise...
It's going to do automatic?
Yeah. Okay. So now, it will go back up to the set speed, right? Which is going to be, I think I set it around, it's 24 right now. And as soon as I put the object in front of it, you can see it starts going down.
It's
20,
down,
19, 18, 17. So it slows down. And as soon as I take it away, it goes back up. And
So
I can always...
You implemented this this thing using a program in Python. The
Yes, Python, yes.
Okay, reduction.
And as soon as I hit the cancel button, you get manual control back to you.
Okay.
Yeah, that was the basis of our project.
Okay, thank you so much.
No worries, man. I hope you enjoyed it. Thank you. Have a good one.